presentation. So today's session. Actually, I decided to give a brief idea about ANSYS analysis. That is 1D analysis. In this 1D analysis, we used to do convert that 3D component into 1D. So for that purpose, I'll give a brief idea about what we have done it to convert 3D models, 3D CAD models into a 2D and also 1D model. Actually, if I'm going to do a simple bar analysis, just take an example of this is my bar. I'm going to apply the axial force at this point, okay, and I am going to fix it here, okay. So when I'm going to apply a force onto this, so this is what the area of the bar. So actually deformation, if I draw a coordinate system, this is my y-axis I can define, this is my x-axis I can define, this is my z-axis I can define. So what are the deformation happening in only x direction, nothing other. Okay. So even though some amount of deformation is happening in y direction as well as z direction also, but amount of deformation happening in the x direction is in a more. That is, the x is very larger than y and z like that. So that's what we are converting. We are now concentrating on the deformation in one direction. So that's what we are doing. We have converted this into a single bar element. We assume this x and with y and z deformations are very less, and we only concentrated on x direction. So this is one thing we have seen. So another thing what we have seen is that we want to convert a 3D model like an CAD model or something into a 2D model. If I have a beam type of the structure, this is my beam. Okay, I'm going to apply the force on transverse force, and this is what fixed end I'm going to have. This fixed end. So actually, what are the deformation happening in this direction is very less, because deformation, whatever it is happening, is in y direction as well as in x direction. So there is less amount of deformation in z direction. That's what this 3D model is a converted into only 2D model, and assume that what are the deformation happening in the z direction in any of the plane. This may be in a one plane, two plane, three plane. All the plane is in the same. That's what we have studied that as a plane stress kind of. So similar fashion we have on a plane strain condition. Similar fashion we have on a accessibility condition. Like so, that's what we have converted that. The reason for this, if I consider any point into the space, I have on a 6 DOFs, that is 6 degrees of freedom. So obviously, I will get on a 6 equation for single point in the space, and that is what gonna basically increases more number of equations into your analysis. If I'm not interested in y direction, maybe z direction, also in the rotation kind of things, what I have to do, I have to reduce these equations and to a single D or something. If I do a 1D analysis, I have a one equation for a single point in the space, or I can say it in a node. And if I have a 2D analysis, I have two equations in it. So likewise, I'm going to reduce the number of equations, and I'm going to have faster calculations. That is what basically intention. That's the reason conversion of 3D model to 2D model is important. Okay. So next part is that when you are doing an FE analysis, first theme is you need to develop a CAD model. That is the first thing. After the CAD model, we are going to do a meshing of it. So that is what it is done by ANSYS itself. After meshing, you are going to apply the forces on it. Apply boundary conditions. It is altogether it is called. In boundary conditions, the fixed positions and forces, movements, all these things you are going to apply. And after boundary conditions, you're going to give this entire part to the solution. In this solution, we have seen two types of solutions. One is called as an iterative type solution, which typically uses a Gauss Sigil type solver, and another one is direct solver, in single step solver. In this direct solver, we use an Gauss elimination type of solver, or you can have LU decomposition and so many other tridiagonal matrix kind of. Once you get the solution, then we are going to do an post processing. Okay. Actually, when we are doing any computational calculations, we are going to spend the maximum time in the modeling. Maximum time it takes that modeling. Second, we are going to get a little time. We need to have a little time, and you need to give a more effort on applying the boundary conditions. Okay? Here you may take maybe 10 minutes or something for model any component. In this application of boundary conditions may not take 2 minutes or something. And then solution is it is already set, means it is already defined in each and everything in the all the softwares. It will do it, and meshing also will take less than 1 minute or something. Here also it will take 1 minute or something. That is what the basically the computational efforts we need to put to get the solution. So to do this, we will solve one simple example. This is what's an example. In this example, you can just look at this is a typical truss bridge. In this truss bridge, this is the point where it is fixed. So this is another point where it is fixed. And these are the beams, or you can remember members of truss are connected, and this is the force it is applied. Three forces are applied at this point, and these are the dimensions given for constructing the. So in this entire stuff, what is to be done? We need to create a model for this. Model means we need to convert this model into a mathematical equation. How can I do it? I need to put these all dimensions, and these softwares are very smart enough. They can do on their all. They will represent all mathematical equations for you, and then it will create a model for you. Then after modeling, you need to go into the analysis part, apply the boundary conditions, and solve. So here, the most important whenever you are doing any kind of an analysis, so it is expected that what is the input you are going to do. So input is first is your model, second input is your what type of material you are going to do, right? Okay. Second, third is what type of boundary conditions you are going to apply. So these are the three inputs you are going to give to the entire software, and then it is going to give an output like it is a deformation pattern it will give. Another one, it will give you stresses in the component. Okay. Also it will give a strain in the component. All these things you can go on defining it. So we will see it step by step how it is done. So first of all we'll move towards an first answers part. So when you are going to start up an ANSYS, you can put up on a workbench here, workbench, and directly you can start and you will get this window. So in this window, left side, you can find so many analysis systems, like already I shown one or two examples for it. In similar fashion, we are going to discuss few practical examples. So in this case, we are doing a static analysis. Basically, static analysis means what are the structures not moving with respect to time, force is not also moving with changing with respect to time. That's what this entire analysis is considered to be a static analysis. So this is one reason. Another reason, if you are going to have any force, practically you are going to apply a force onto any component, it is all the time it is changing, its boundary conditions are changing, practically it is going to happen it. But when you are doing an analysis, we are assuming that the entire force is remaining constant. So that is what you are assuming. But when you look at the application of force, is having in a two parameters. One is its frequency, another is its amplitude. If you are going to that force having a certain amount of frequency, just take an example of stool on which you are going to keep your note and all the day you are not keeping the books on that particular stool or table. Okay? So you may be picking up for some time and then you are going to keep it. So whatever the amount of frequency you're going to apply the force on the stool is in a very low as compared to it's a natural frequency, and that is the reason. So if it is what are the natural frequency is very low, that kind of an what are the external force application for it, right? And for that purpose there is a certain frequency, that frequency is very low compared to its natural frequency. Then this type of analysis can be as treated as a static analysis. We'll discuss this in more detail in the dynamics chapter. So here we'll now start with a static structure because we are doing a static analysis, the static structure. So if you look into this, last time I shown you some examples like why there is a question mark, why there is a right check mark or something. So here it is an engineering data. You can go and look at what type of material you have included. This is a static structure. I will tell you this entire material entry part in different session. But now this is what on a default material you are decided. If you want to add up some new material, you can just put up a name for it and you can start adding the material. That is one thing. Another one, you can collect and right click onto this. You can collect the material already available from the library. So basically, this is what in the first step, which is right check because it is default material it has taken as in a structure ST, having the Young's model is 0.1 into 10 raised to 5 and Poisson's ratio 0.3 something. So here we will now move towards a geometry approach. Okay? So we will create a geometry. Geometry means we are going to create a CAD model. When you look at this geometry, you can observe there are certain tools available for you. There are three planes. This is the XY plane, then YZ plane, and then XZ plane, all these three planes. And below you can find in a parts and bodies or something. This is one thing. Another thing, if you look into the above part, you can have a different features. There is you can select a point here, you can select a line here, plane here, and then entire body also. You want to sketch onto particular XY plane. So that's what I will select, look at the face. So I will look at the 2D face something. Before moving to any model, it is requested that you first of all set the type of unit you are using. If you are going to have a millimeters, you set up an for millimeters. But before moving to that, my request is that we just look at what type of dimensions are there. It is in meters, so obviously I will select meters for. Okay, it is millimeters, and I will select for a meter. So when we are going to create a model for it, so you go into the sketching. Okay, you need to just draw on the lines. So you need to draw a line. Before moving to this entire analysis, one more point I missed here is that I will just close down this and I will complete that part and I will come back. So in geometry, whenever you are doing any kind of analysis, it's expected that you're going to have to set up an analysis. So here it is on a 2D analysis and kind of things. So in this case, okay, this is geometry. Here there are certain settings. We need to do it. So here it is analysis type 2D. Okay, maybe some here it is somewhere it comes upon a line models. Somewhere I'm going to miss it. I will just delete this part and I will once again that will. Okay. I will go into the model. Here you will get the solid bodies. Here I will still click on to the line bodies. Okay, only line bodies I need to take it so that it will convert whatever the analysis you are going to do. It will be converting into line bodies, not into 2D or 3D models. Okay, so and single line will be treated as a body. So we'll now move towards a design model. In this design model, just select on a plane, XY plane, or any plane you can select and go on stage. So then I can look at the face, select the units. I'll select into the units. here it is in a scale is given. From here it is in a 0 and it is 30. I can zoom on or I can zoom out. So that way also I can do it. And then now go into the sketching. Okay. In this sketching, you can start drawing in whatever your model. How can I start? I will now start with this is one element, this is my second element, third element, fourth element. Altogether dimensions from center, this I can consider as a center. This side it is a 2 meter, right side it is 2 meter, left side 2 meter, like this. So I can now draw on a line from the center, this side 1 meter, and give the dimensions. Immediately give the dimensions for this. So this is 1 meter. I can set it to the 1. So then next I will now connect this second element to this, and I will give another dimensions for this, and this is again for 1. Okay. Similar fashion I can have on other end. So this is 1 meter and this is another one. Okay. Then 1, 2, this 1. This is again 1. So I got now these 5 points onto downward part. Okay. So now what is to be done? I need to go it 1 meter above. Okay. I can now draw on one line above this. So now I can go into this. I can have this line 1 meter above. Then I can go into the dimensions. I'll give a for it. So it is 1 meter. So similar fashion, I can have how many lines, vertical lines I need to draw it? 1, 2, 3. So same, I will just repeat it. 1 here, line, and then third line. In ANSYS, so you will find difficult in modeling. The reason for this is the software which is typically used for analysis purpose. It is not used for modeling purpose. That's what you may find in a difficulty in creating a model. So this way we created this. So next step is to join these lines. Okay. So we have joined these 3 lines. Now you need to connect all these lines. So just draw these lines. This is one line to connect it to this one, and then second one, third one, fourth one. I need to give a ribs for it. This ribs. So it is showing some dimensional constraint. Don't worry about the dimensional constraint. Okay. This way we created an entire model. So in this way, we have created an entire model. Then you need to go into the again back to the modeling. We have created only sketch. Here, if you look into the parts, you will find 0 parts. So this particular sketch, and this is having in a particular dimension. What are this line has having in a typical dimension. This is what an entirely approximatic shape. Okay. So for that purpose, you just look at what is its shape, what is its size. So height is it is a rectangular cross section having a 6 by 6. It is a square shape. So member cross section centimeter by 6. Okay, 6 centimeter means 6 divided by 100 will give me an 8 meters. So for that purpose, what I have to do, I have to go into the answer. I have to create an lines from sketches. This is what on a lines. I need to create an lines from the sketches. Okay. I'll now say it is in a generate. Okay. I need to select this. Sorry. Delete this once again. I done a small mistake here. Line from sketches. I'll say it is an upper one. And then I will say generate. It has a created in a line body. But here it is asking some cross section. Okay. I need to define that cross section. Okay. So where I can go into the cross and here in this here I can go into the different cross sections. You can select a rectangular, circular, circular tube, so many other sections. We have to go for a rectangular cross section. It will show you the dimensions. So here it is on a, how much it is going to give? Zero point 0.1. Zero point 0.01 is 10 mm. 0.01 means 10 mm. Means altogether I have to 1 centimeter. Likewise, I need to go for 6 centimeter here. So similarly, I will go for another 6 per centimeter, that square section. Okay. So once I define this section, okay, I need to assign this line with that particular section. Here I have given the name as a rectangular. Likewise, I can define number of cross sections. Okay. Now I can select here cross rectangle, and then I will say once again generate. It has now assigned this. So this way we created an entire model for it. Once we create this model, okay, now you can close this and come back to your ANSYS. This way it is now geometry is ready for your further analysis. Next part is you need to create in a model. Okay? And then you go into the model. In this modeling, what is the next step? I need to create a mesh. Okay. After meshing, I need to apply the boundary conditions. And then I need to fire a simulation. That is what we need to have one of these steps we need to do. So whenever it is importing any kind of model, it is that whatever the analysis needs in a kind of a process. That process is called as an attack. It's taking some time, and if your model is bigger enough, so it will take too much time for importing. So this is what on a line model we created. I think it is visible to everyone. So I can now just look at this model. Okay. So you can just go into the geometry. This is what in a geometry model. This is having, if you look into the, this is what on a rectangular shape. So in a smaller size, that's what you can't see here. So if you want to assign in a particular material here, just go into the geometry, go into the line body. Here you can assign in a particular material. And here it is a defaultly we decided for a structure of steel. In this machine, what you can do is we can define in a size for it. Okay, so you can put as it is, don't worry about it, and then you just say it is in a generator image. It will create an image for you. So this is what the way it has a created image. This altogether per member is divided into number of bar elements. This is what on a bar element. This is one bar element, second bar, third bar. How many number of elements it has created? You can just look at the statistics. It has created altogether 73 elements with 141 nodes, means altogether 141 nodes, having each equation in one for each node, because it is one analysis. It has created 141 by 145. That is a stiffness. So that is what the way you can just look at it. So next part is I need to apply the boundary conditions. What are the boundary conditions for this case? So it is fixed here, another fixed here. Okay. So here you can now apply a fixed support. So I can go and select the fixed. So in this fixed support, when you look at above here and in the icon here, you can find there are different ways that you can select. This is what on a face you can select it. Here it is edge you can select. Here it is on a point you want to select. So I want to select on a point. That's what I'll click onto the point. I'll click onto this part as well as control and then click onto apply for. What the way you have applied for. Okay. Now you want to apply the forces. Okay. What are the locations of the forces? These three locations of one, three. So obviously I will now select these forces. In right click onto this, insert. So this is one point. This is my second point, and this is my third point. And apply it. I'm going to apply the force in which direction? I'm going to apply the force in y direction. So that's what I need to, instead of vector, I need to go for y. How much force I'm going to apply? So that force is 30 kilonewton. What are the force you are going to apply? Here is in Newton. So obviously 30 e raised to 3 I can write. So it will give me a 30 kilonewton. But in this, you can just observe the direction is in upward direction. Okay. So this is one way I can do it. And now the same force is applied on the all the three nodes. But you can just look at it only one point. Okay. So if you want to remove it, and so you want all the places to be done. So you need to do it individually. Okay. So that is what I will show. This is insert. I'll apply the force here, 30 kilonewton force. Apply. Select a vector to the components. So I'll write 30 raised to 3. So this will give upward direction. Now change the direction to the minus. Will give them negative. This is one way you can do. Another way you can do that I will tell you in later stage. This is one force. Similar fashion, I can have another force here. Apply it. Select on a components. Minus 30 e raised to 3. And third force, apply. Here it is in the components. Minus 30 e raised to 3. So that way I can now get in all the three forces. This way you can just look at your entire model is now ready for your analysis. So what kind of an output you want? You want a deformation. What I will select a solution here. In this solution, you can just look into the solution information. So here it is in a solver output, Newton-Raphson residual method, update interval 2.5 seconds, and something is there. Don't worry about this. There is one more thing here is analysis setting. This analysis setting, solver type, you are keeping it as a program control. There will be a 2, 1, maybe direct or iterate. So we can select whichever it is applicable. Otherwise, you keep it program control. That will be better. In solution, you can go into the total deformation. You want it. Another one, you want to know beam results. Beam tool, I will use it. In this beam tool, I can determine direct stresses, combined stresses, minimum and maximum, all this. Along with that, I want to know the forces also. I want to know the reaction forces. I can now select on a particular point onto the space. This is one force, another one. I want to select on these 2 points, fixed support. So these are the two fixed supports, and it will determine the reactions. So once we complete all this analysis, so it is expected that you should start on a simulation. You can just click onto the solve. It will start getting. Now it is showing deformation altogether maximum deformation is 0.39. It's very low, and it is auto scale. It is set to here. If you set into the true scale, you can just look at there is very less amount of deformation. Okay, this is what in a rectangular section you can just look at. How much amount of stresses it has generated? 8.1. Okay. Minimum 8.919 and compressive stresses will be -7. Okay. Combined stresses 7.8 or something. Maximum and minimum both the things are. So you want to see the reaction. How much reaction we got it. Altogether, we applied a 30 plus 30 plus 30. These three forces. Altogether 90 kilonewton. Okay. So if you look into this point, particular point, if you select on a force reaction, here it is on a force reaction in x direction. It is somewhere it is almost it is equal to 0. But in y direction, you got on a 90 kilometer. In z direction also, you will get on a minus. Somewhere it is almost 0. It is not coming to in a 0. The reason is that we are doing all approximate. That's what minus raised my e raised to minus 10 means it is too much. 10 raised to minus 10. Awesome. Okay. So here reaction force is 90,000. So you applied in a third 90 kilonewton and you got in a reaction 90. So your entire analysis is perfect. You need not to worry. Here also you can observe. Here at this place, get this. If I want to do something change. I want to apply in a force horizontal direction at this location. In this, these two forces I want to apply. So I would like to see how it affect to a reaction. Okay? So I can now insert a force onto this particular point, apply it, and I want to give the force in x direction. That is 30. Positive side 30 kilonewton. This is what on a reaction. Okay. So if I apply this force and I want to do once again this relation, I can now simulate it. Okay. You got in some different pattern of deformation. Previously it was 0.39, it has increased to then a point. It's a total deformation. If you look into the deformation, typical deformation, I want to see it in x direction deformation. So instead of total, you can directional deformation. You can convert x direction. It is already selected as an x direction deformation, and you can say it equivalent. So in x direction, you got here 0.12. Okay, so it is a very less amount of deformation. And similarly, if you want to determine a deformation in y direction, I can now y direction and then evaluate this. Here you will get a maximum deformation is 0.39. That is a negative value. So this way, this is the way you can do a simulation for any model. So when you are going to create a report out of this, this is what an entire analysis you got. You want to have a report. So you can just go into the print preview, you will get in a PDF. Another report preview means it will generate all the information, your input information, material information. This is what an entire PDF it generates. What are the information, material property, maybe boundary conditions, each and everything will be included. And then if you want to create in a PPT out of it, in a very nice way you can do it to this. This is what I can do. Model. This is my mesh model. This is boundary conditions. Okay. I want to now create in a PPT out of it. It's in a very simple one. You can go into the print preview. Okay, so this is what you done it, and then I can just go into the send to PowerPoint. Also, I can go into the Word document. If I look into the PowerPoint, okay, it will go on including in this all information into the PowerPoint automatically. Okay, so if I want to send it this deformation pattern to the PowerPoint, you can go and it will create an automatically another slide for you. You can put, so this is what the way you can do it. Another you want to have an force reaction or something. So here it is now, previously the force reaction was in a vertical, it is now angular. The reason for that we have provided one more force as an x. Okay. So you can have on a PowerPoint here. Here it is in a stresses also you can include into this. You can go on including into the PPTs. It has created the PPT, at least 4 PPTs. So you can use this information for your presentation. One way you can do it. Another way you can create your Word document also, entirely a single Word document. Okay. In this single Word document means when you are going to write in a report, so this information which will be in a much more helpful when you are going to do this. And last one, you want to email or something as an attachment, that also you can send it. And also you want to create a print PDF, you can get the PDF. There is no big deal in it. Okay. So this is what the way. Whenever you are going to write any report, make sure that you are going to do this all. Okay. So this is all for today. This is for one model. Similar fashion, we can have different models. We can do an analysis. I will just show you this and. come back to this is one model we have done. Similarly, we can have a roof truss type of analysis. Okay. That is Douglas per material you can use, and you can truss. Another one, you have on a tower crane. We'll solve one out of it, then we'll move. This is what a tower crane model. The force is applied and all. So then we can have on a truss transmission tower. You want to do a transmission, that is electrical transmission. You want to do the analysis, weight and each and everything you want to do, put onto this, and whether that entire structure is stable or unstable. That do the study. So this type of structures you can do analysis. My request is that you need to complete all these four models as an assignment for you. We'll put that assignment onto the Moodle kind of things. Okay. So I've done this entire analysis for you. I will show you how it is done. What on a back to here and as a process. This whole other structures that is analyzed here altogether. This is what on a bridge truss. So similar fashion, you can go on adding more and more CAD, that is analysis, ANSYS analysis. This is what on a bridge truss analysis. This is what on a electrical transmission analysis. This electrical transmission structure analysis, you can just open up. You can the results. This is what on a electrical transmission structure. Here it is a entire structure. It is shown. It's showing 19 mm kind of a deformation, and you can have an stresses in the member. It is as 268 something. That is you can just identify the places where it is going to fail it. So this is what the place where it is getting a more stress. Obviously, crack will initiate there, and there is a possibility of failure in that particular. So this is what the entire electrical transmission analysis. Similarly, you can have a crane analysis. The crane analysis, the same way you can look at deformation patterns. So this is what a deformation was happened. And if I want to animate it, that also it will come to your analysis. Along with that animation, you can save that animations to file also. So that is what you can do it. Here you can just say animation that I will set it in crane or something. Stop and I okay. I need to set a word set window setting that I need to set to the arrow to a normal, and then get the saving of this area. Similar fashion, you can have a timber structure analysis. These are the different forces applied at different locations. Okay, so this is what a deformation pattern for it. At how it is going to deform the structure. So this is what on a somewhat exaggerated. True scale will show you very less amount of deformation. Not sure. So if you set into the auto scale, maybe auto scale somewhere here it is, you can look at the auto scale. It will exaggerate your deformation. And you can look at the direct stresses. So it is somewhere it is coming 20, and like this. So this is for entirely today's session, and you can complete your